For our lesson number 6, we have the equilibrium of concurrent force system. In static, a body is said to be in equilibrium when the force system acting upon it has a zero resultant. So we have here the summation of fx is equals to 0, the summation of fy is equals to 0, and lastly, the summation of moment is equals to 0. So we have here the common support that is used as an example, or commonly used as an example, which is the roller. And the reaction on roller is only 1. And the hinge, we have 2 reaction. And the fix and the cable with 2 reactions and the smooth surface. So the important points of equilibrium of forces are: 2 forces are in equilibrium if they are in equal and oppositely directed. And 3 coplanar forces in equilibrium are concurrent. And lastly, 3 or more concurrent forces in equilibrium form a closed polygon when connected in head-to-tail manner. We have here problem number 1, and it says the 100 pounds force and the 200 pound force shown in the figure below are to be held in equilibrium by a third force J. Determine the value of J. So we have here our figure, and here's our 100 pounds and our 200 pounds, and we have to find the value of J. And in 200 pounds, there is an angle of 30 degrees. So to solve our problem, we have to use the cosine law, or using cosine law. Here's our figure, and the formula of cosine law is a square root of a squared plus b squared minus 2 times ab times cosine angle. So we have to input our forces into the given formula. So our A is 200 pounds and our B is 100 pounds. So we have here to find the value of J. So J squared is equals to 200 squared plus 100 squared minus 2. Input the A, which is our 200, times 200 and times 100, our B, times cosine and the angle, and that is equals to 100 or 15358.984 pounds. So we have to square our final answer. So square root of 15,358.984 is 123.931 pounds. So this is the value of our J.